part 2 of this, and what we're going to do is we're going to basically be writing these in standard form or simplifying as best we can. So we don't, just like when we have radicals in the denominator, we don't want imaginary or complex numbers in the denominator as well. And some of that has to do with programming, etc., etc. But this is going to be an expectation in your college courses as well, so we need to practice this pretty thoroughly. So what we're going to do is we're going to use the identity number, which is 1, and we can multiply any number by 1, and it remains itself. That 1 can come in many shapes. This shape is going to be conjugate of 4 minus 5i, and that's going to be 4 plus 5i over 4 plus 5i. Okay? So we're going to multiply these two. And that's going to eliminate and give us a real number in the denominator, as we saw in the previous video. So this is nothing more than 2 times 4 plus 5i. And I'm going to go ahead and use the shortcut because I already did the full binomial. So that's going to be 16 minus 25i. All right? Squared, that is. So we're going to have 16 minus 25i squared. That's just going to be a positive 25. That's going to be 41. So this is going to equal to 2 times 4 plus 5i over 41. And I can distribute the 2 and call that 8 plus 10i over 41. All right, so here's an interesting example. So we're going to have to multiply the conjugate on each one. So the conjugate being 1 minus i, and the conjugate for this one, 1 plus i. Let's go ahead and take a look at this. So we're going to have 2 over 1 plus I, and we're going to multiply by 1 minus I on the top and on the bottom. Okay? And of course, we're going to subtract 3, and this is 1 minus I. So we're going to multiply 1 plus I on the top and 1 plus I on the bottom. And we've got to be a little bit disciplined here. I can work this up here because notice this and this are the same. I'm going to get the same number here and the same number here. So a times b is b times a. So up here I'm going to show you 1 times 1 plus I, 1 minus I. All right? That's just going to be 1. Distribute, that's negative I, that's positive I. Those cancel out. And then I, negative I squared, that's a negative 1. So it's going to be 1 plus 1 is equal to 2. So my denominator turned into 2 on both of these. I'll go ahead and distribute the 2 here. So that's 2 minus 2i over 2. And I don't want to simplify this. And that's going to be minus 3 plus 3i. Okay? So this is going to be 3 plus 3i, also over 2. We're distributing that negative 1 on the top. So we're going to combine like terms. That's going to leave me with a negative 1 minus 5i all over 2. So let's continue and look at a couple of more interesting problems. All right? So now we're going to simplify and write in standard form, but let's visit this first. It's a good idea to have this memorized, or at least be able to recreate it. So look at the pattern here. I to the first is just I to the second is negative 1. We talked about these previously. I to the third comes to be negative I to the fourth becomes a 1. So let's take a look at the pattern. We go to 5 and we go back to I, 6, negative 1, and so on. So what is happening here is if you divide by 4 and your remainder is a 1, remainder is a 0, it's going to equal to 1, and so on. This is I to the nth power. So I have I to the 20, and I divide 4 into 20. That's going to be an even remainder. That's going to be, so I to the 20 is equal to 1. So if I do something a little bit more complex, like ai to the 87th power, well, I know that 4 doesn't go into it. I know 2 doesn't go into it. So what's it going to be? Let's see, if I were to actually work it out, 4 into 87, all right. Well, I know it goes into 84, so the remainder is going to equal to 3. So if the remainder is 3, this is going to equal to negative I, all right. Okay, so let's go ahead and move on. What do we got next? That is it. I thought I had another example for you. Well, I'll just go ahead and get this posted and go on to the next topic.